We are at day 4 of Supercomputing 2022 in Dallas, and we have just left the awards ceremony. And I'm here today with Torsten Hoefler and his team. This year has been quite successful for you and your team, Torsten, so congratulations. Now, I would like that you walk with me and introduce me to your team and their work and what they want, basically. Okay. So we will start with your awarded student. And so, Torsten, I let you introduce your student.
Oh, okay. So this is Marcin, my student, and I think he can speak for himself. So I will give you.
I'm Marcin, and I've been working with Torsten for the last 4 years on serverless computing, and our work where we try to explore how cloud programming models like serverless can bring improved efficiency into HPC cluster. Our work has been awarded by the ICM and IEEE with the George Michael HPC Fellowship for bringing this novelty of cloud into working on this cloud and HPC convergence.
And then you have also won a second award, right? For
correct. I also presented a poster at the ACM Student Research Competition where Torsten and Alexandru, our postdoc, advised me on this project, where we also worked on exactly this problem of trying to figure out how to fill the missing underutilization gaps in the HPC cluster by incorporating serverless functions to let other jobs to use that resources.
So this supercomputer has been extremely successful for you. So now you go back to Zurich and you will have more work to do, I guess.
Absolutely. I think we already have plans for the next year, SC.
Very good. Thank you very much. So Torsten, who's next?
I would say Alexandros is next. So he has been tirelessly working the last 6 months on a very special project that I want to particularly thank him for, even though some people say it's a thankless work, but I'm very, very thankful. So Alexandros.
Well, thank you. So here we have been administering a part of the student cluster competition, the reproducibility challenge. So this was based on our last year's papers for Python, productivity, portability, performance, which is based on the data-centric framework. And this was a great success. I think the competition went very well. Other than that, we also had a paper with my colleague Greg that you will talk with him later. And I also had my doctoral showcase.
So congratulations, Alexandros, another very successful postdoc, PhD. He finished, right? He just finished. And here are the next two. Please introduce yourself.
Okay.
Why are you a supercomputing?
Well, that's nice. Actually, we're exploring a really interesting question here. So we were working together with CSCS and together with also the Allen Institute for Artificial Intelligence on asking this question of, can we take, Python and use that for complete atmospheric models and do it fast and in a productive way, and we actually succeeded. So that was a really interesting paper.
Sure. I'm a new PhD student since 1 year now under Torsten, and this year at SC I presented a work where I tried to interactively visualize the data movement of an application to essentially eliminate the need for profiling or using performance counter for determining of performance characteristics of an application, and instead giving you performance results within seconds and milliseconds. Yeah.
Thank you very much. So, Torsten, Niels Veli this morning said that we have to prepare ourselves for the data deluge. Are we ready for the data deluge?
Absolutely. We actually have another work in my group that is not represented at supercomputing, where we achieve more than 3,000 times compression of weather data, that data that Niels was talking about. But that is not SC22, that may be SC23.
But do you agree that there will come a data deluge?
I hope we can solve it. But yes, it will be coming.
Before it comes.
Yes.
So we are at the next. Group of people here. We have Maciej that has also won the best dissertation, so congratulations for that. And this is the best papers at Supercomputing 2022. Please introduce yourself.
Okay, hello, I'm Maciej.
I'm Paolo. Flavio.
And Greg.
What was the best paper for?
So best paper is about, so this is about prop graph, which is really a new paradigm for delivering high performance and high accuracy graph mining algorithms. Important problems that we use in things like social sciences, biology, chemistry, and in plethora of other domains.
Thank you. And so, why do you think it's important to have a best paper as supercomputing? Who wants to answer?
Well, maybe this is some way of filtering what is important and what is the most important. Because all papers that are accepted as SC are extremely good works, but then among all these works, you need to somehow filter out what is the... Maybe they are setting trends, for example, where we can go from here.
Torsten, why is it important to be a best paper as supercomputing?
Well, I think...
if you have anything to add.
Yeah, so no, I have nothing to add.
So congratulations then, and good luck for the next one. Okay, and now here we go to the award, to the Reproducibility Advancement Award. Torsten, Salvatore,
Daniele.
and Daniele. Torsten, or any one of you, can you explain to us a little bit what is this award?
So this newly introduced award at SC22 basically deals with the reproducibility crisis that people have been talking about in physical engineering and also medical sciences. And the idea is to award the best paper in terms of its reproducibility. So which means that at SC we have reproducibility packages. So these packages provide all the source code and all the artifacts that scientists later can build on to recreate these results, but also to extend these results in new ways. And particularly our paper has been already reproduced by various other places, for example, in industry, and the reproducibility package has been, I would say, a very interesting success in this sense. And it was mainly due to one of my students who can unfortunately not be here because he is already at an internship with Microsoft working on similar things. So that was also a success. And but I would like to give the word to Daniele, who can talk a little bit more about the actual details of this.
So basically, this paper was about designing a new interconnection network specifically targeted to machine learning workloads. So we had somewhat to assess the performance of this network. So we extended an existing simulator by implementing this interconnection network and comparing it with a bunch of different other interconnection networks that are already existing. So this required a lot of compute hours for running all these simulations. And this would not have been possible without the support from CSCS. So we ran, I think it was 0.8 or 0.6 million core hours on the ELP supercomputer, actually. And I will give the word to Salvatore for some more details about the simulation infrastructure.
Thank you. I want to outline how this work actually required to extend the simulator Daniele was mentioning in order to support new large-scale collective operations optimized specifically for this new topology, and additionally to deep learning workloads in order to produce benchmarking results. And all these changes and new introductions will be are actually already shared with the community in order to foster future research.
Yes, thank you, the three of you. I have another question now. Maybe it's a trivial. I'm sorry about that. But how much work? How much in advance do you start brainstorming these new ideas and to produce a paper to submit to supercomputing?
I mean, it's very different. We generally don't start by thinking about a paper at supercomputing. We start a piece of research. So we start with an idea. Right? And with that idea, I mean, for the Hemming mesh, for example, that idea came during my sabbatical at Microsoft in 2019. So, and then of course it took a while to mature and solve all the IP issues, and then it comes to fruition in 2022. So it's very, very different. Sometimes the idea comes relatively fast, and it's a little but nice idea that we push forward. Sometimes it's years of work. So it's really the papers that we have at supercomputing span from the 2019 that I just mentioned, so 3 years to, I would say, at least 6 months. So it doesn't really get shorter than 6 months.
But where do you find your inspiration, Torsten? I'm curious because you have a very successful group. You always attract extremely smart and good students. So where your inspiration comes for your research, of course?
Mainly from the community. So I mean, the HPC community is just an amazing environment to strive. Right? I mean, we are all here at this conference. We meet regularly. We have lots of interactions. I mean, my group is always present with lots of people. We have a very large number of people here. And so this is where it comes from. We actually also read a lot of papers. I mean, this is the obvious thing, and have interactions with industry. But it's really the HPC community, which is industry, papers, this conference, very much.
So, Torsten, so you're telling us that there is a real value in coming here, supercomputing, because you need to sit with people, you need to interact and discuss with people to also check whether your thoughts and your idea. Is this correct?
Yes, this is correct. But in addition to the interaction, the international interaction, the interaction that's really, really helpful for our research is the interaction with you guys at CSCS. I mean, we've been using the system, the ALP system, in pretty much all of the works that we looked at. Maybe not all, but a very large fraction. And we also get inspiration by interacting with the real practitioners. I mean, installing these systems, working with these systems. And I'm looking very much forward that we are soon going to sit in one building.
Yeah, thank you. Actually, this was also our wish. It's very nice to collaborate with you always. Thank you very much, and see you in Denver next year.